And that's what we will look at numerically. So for the simplest case, we will look at quadratic expressions centered at 0. So everything is about powers of x and powers of y. No x0, no y0. And the constant will be 0. So we will look at the basic quadratic functions. And that's what we will have to decide given a function like this. Does it have minimum or does it have maximum? And of course, this demonstration from Wolfram, this is one of many demonstrations you can find on Wolfram website. People create those little files like demonstrations I have on Blackboard. So people create them, upload there, they put some comments there, so you can go there, browse, and they're covering all kind of areas like geometry, physics, electricity, anything. So I just picked this one, and it shows the graph of the function. So the function is that one, and the right hand side is the map of the graph, the level sets. So if the function is like that, the function clearly has maximum at that center point. Now, how can we decide by looking at that function whether it has maximum or not? Because, well, if you change the coefficients to all positives, it will definitely be minimum. And moreover, you can if you make this middle term 0, then what you see is, what you see is a sum of squares, right? If you see a sum of squares, is it ever negative? No. So the 0 value at the point x equals 0, y is equals 0 is the minimum. And that's obvious without even graph. It's obvious from the formula of the function. And of course, if you have those squares with negative coefficients, even if the coefficients are different, right, it's still going to be maximum. Because those squares are never negative, and they come with negative coefficients, so everything becomes negative, except at 0. So 0 is maximum. So the easiest cases are when you have only squares, and you have both of them the same sign, both negative or both positive. Now the interesting case is when one square positive and the other negative. So then the function is, or has the shape of saddle. Basically, one positive square in, if y is 0, then this positive square makes it look like parabola that is concave up. If x is 0, that negative square makes it look like parabola concave down, and the function as a whole, on the whole plane, kind of joins these two parabolas together, making this saddle. And you may want to look at, I don't know how to scroll to the right. Well, anyway, this is the shape of the function, and you see if I change the coefficients, and the coefficients are still of different sign, the shape is still the same. It's still the saddle. Now, what if I add the xy? Well, it remains the saddle. But the thing is that you cannot decide in general about a function like this just by looking at coefficients with x squared and y squared. So sometimes the result will be a saddle, but sometimes it will be maximum or minimum. Not in this case, I cannot make it maximum or minimum. But if you make it like this, well, this is maximum, and if I add a little xy, it's still maximum. But if I add a lot of xy, it becomes a saddle. Or if I subtract a lot of xy, it becomes a saddle again. So it really matters how much you add or subtract of xy in comparison of what you have. And of course, if your coefficients are different, well, it's usually hard to decide by looking at those numbers. So that's going to be our basic task. Given a formula like this, how to decide whether you have maximum or minimum. And we better do it without looking at the graph, without plotting the function, by looking just at algebra and doing very basic completion of squares. Because completion of squares is going to be enough. Now the only other example to look at would be having just xy. So that's going to be our basic example of a function. So if you have xy, you have a saddle. And no matter if it is negative or positive, it is always a saddle. Okay, so having an idea of how the functions look like, let us do some algebra. And of course on the test you have to explain algebra without plotting